Hello learners. Today's session I'm going to talk about applications of data science. What are the common misconceptions of data science? Who are the different individuals who are involved in the data science project? And why do we need to define the life cycle of data science projects? Usually, the life cycle of data science project involve different phases, including data science project requirement analysis phase, data collection and preparation phase, descriptive data analysis phase, data modeling and model testing, followed by model deployment and refinement. If you remember, in the last class, we covered what are the different attributes type, what is the data objects, different types of data sets. Then we also discuss about the different types of statistical data types, including categorical data and quantitative data. Measuring the central tendencies, dispersion of data, scale of data was also covered. Followed by, we also discussed sampling, different methods for data analysis, including descriptive analysis, inferential data analysis, predictive analysis, and some part of data science application was also covered. Today's session also I'm going to start with the application of data science. So data science is useful in analyzing large data sets to produce useful information that can be used for business deployment and develop in decision making process. Some of the application of data science are application using similarity analysis, application which are related to the web searching, and application which are related to healthcare domain and transport sector domain. Let's look into these applications one by one. Application using similarity analysis. Basically, these applications use similarity analysis of data using various algorithms, resulting into classification or clustering of data into several categories. Some of these applications can be spam detection system, financial fraud detection system, recommendation of products. In spam detection system, the system classifies the email into spam and non-spam categories. It analyzes the IP address of mail origin, word patterns used in the mail, word frequency, etc., to classify whether a mail is spam or not. In financial fraud detection system, which is one of the major applications for online financial services, basic principle is once again to classify the transaction as safe or unsafe transaction, which is based on the various parameters of the transaction. In recommendation of product, several e-commerce companies have the data of your buying patterns, information about your searches to their portal, and other information about your account with them. This information can be clustered into the classes of buyers, which can further be used to recommend various products for you. Application related to the web searching. These applications primarily helps you in finding content on the web more effectively. These algorithms attempt to find the good website based on the search items. They may use tools related to semantic of your term, indexing of important website, and link analysis, etc. Coming to the healthcare system, the data science can be extremely useful for healthcare application. Some of the application may involve processing and analyzing images for neonatal care to detect possibilities of tumors, deformities, problems in organs, etc. Also, there can be application to establishing a relationship of diseases to certain factors, creating recommendation for public health based on the public health data. For example, genome analysis, creation and testing of new drugs, etc. Also, the possibilities of use of streaming data for monitoring the pattern is also another potential area for use of data science in healthcare domain. Coming to the transport sector, these applications may investigate the possibilities of finding best routes, air, road, etc. For example, many e-commerce companies need to plan the most economical ways to logistics support from their warehouse to the customer. Finding the best dynamic route from a source to destination with a dynamic load on the road network, etc. This application will be required to process the stream of data. So in general, the data science can be used for benefit of society. It should be used creatively to improve the effective resource utilization, which may lead to sustainable development. The ultimate goal of data science application should be used to help us to protect our environment and human welfare. Let's discuss about what are the common misconceptions of data science. There are correlation is not a causation, followed by Simpson paradox and data dredging. Correlation is not a causation. Correlation usually describe the patterns in mutual relationship between the variables. So if one variable changes, the other tends to, and vice versa. It does not matter which one we start with. But causation goes a step further and describes a relationship between the variables that have an action and a direction. For example, if the value of one variable increases, it causes the second variables to increase as well, but not the other way around. Let's consider one more example where we have three variables, namely attend, marks and study to represent attendance, marks and study of students as shown in the diagram. While analyzing data, you found that there is a strong correlation between the variables attend and marks. However, it does really matter that higher attendance causes students to obtain a better marks? The answer is no. Another misconception, that is Simpson paradox. Simpson paradox is an interesting situation which sometimes leads to wrong interpretation. Let's consider the two universities' data, say University 1 and University 2, and the pass out data for their universities. As you can see in the table, for University 1 and University 2, University 2 is performing better as far as passing percentage is concerned. However, during the detailed data inspection, it was noted that both the universities were running basic adult literacy program, which in general has a slightly poor result. Further, the data of literacy program is to compiled separately. Therefore, the data for the university would be something like this table. You may observe that due to the additional grouping to adult literacy program, the corrected data shows that University 1 is performing better than University 2. As the pass out rate for general program is same, and pass out rate for the adult literacy program is better from University 1. You must note the changes in the percentage, and this is the Simpson paradox. Third misconception, which is data dredging. Data dredging, as the name suggests, is an extensive analysis of very large data set. Such analysis results in generation of large number of data association. Many of those associations may not be causal, thus requires further exploration through other techniques. Therefore, it is essential that every data association with a large data set should be investigated further before reporting them as a conclusion of the study. Data dredging, which is sometimes also known as data snooping or p-hacking, is the misuse of data analysis to find patterns in the data that can be presented as statistically significant, thus dramatically increasing and undertaking the risk of false positive. Let's talk about who are the different individuals who are involved in data science project. Let's look at some of the different people who are involved in the data science life cycle. We have domain expert, we have a business analyst, we have a machine learning engineers, we have a data engineers and data architect. Domain expert, as the name suggests, they are usually those people with a substantial experience in any particular domain or industry. Whereas business analysts are those who can understand the business needs of a particular domain or industry. Their main responsibilities include finding the right solution and timeline of the said needs. Whereas machine learning engineers bear the responsibility of providing advice regarding the kind of model to be applied to generate the desired output. Furthermore, they are also required to come up with the appropriate solution for the correct and required output. Data engineers and data architect are considered the expert in the data modeling, starting from data visualization to storage and retrieval of data. All are done by these individuals. Now, question arises, why do we need to define the life cycle of data science project? A data science project typically has data as primary component. As a result, in any life cycle of data science project, before beginning the data science project, we have received from one of the customer or a client, we must first comprehend the fundamental problem statement that was supplied. After comprehending the business issue, we must collect the necessary information to resolve the use case. However, many questions come up for the newcomers, such as what format is the data needed in? How do I obtain the data? What should we do with the data? There are many such questions, yet there may be many different answers. So the data science life cycle makes all of it easy. Now we will discuss about the life cycle of data science based applications. In general, data science application development may involve the different stages, starting from data science project requirement analysis phase, data collection and preparation phase, descriptive data analysis, data modeling and modeling testing, and model deployment and refinement as shown in the diagram. Data science project requirement and analysis phase, the first and foremost step for data science project would be to identify the objective of a data science project. In certain situations, figuring out the issue is very simple, but sometimes the customer will make a clear request, whilst others may ask you to solve a very broad problem. This identification of objective is also coupled with the study of benefits of the project, resource requirement, and the cost of the project. Also, you need to make a project plan which includes project deliverables and associate time frame. The data that is required to be used for the project is also decided. So basically, this phase is similar as the requirement study and the project planning and scheduling phase. In the second phase, which is data collection and preparation phase, here what we do is to gather the useful information from the data sources available. This phase, first all the data sources are identified, followed by designing the processes of data collection. If you engage with the company's team, you may learn more about the data that is available, what data can be used to solve the problem, and other details. The data must be described together with their type, relevancy, and organization. Sometimes visual charts are also used to investigate the data. There are special packages to read the data from specific sources such as R language or Python language. You may find numerous kinds of databases such as Oracle, PostgreSQL, and MongoDB. Alternative to obtain data through web APIs and calling data. We also have a social media data where the sites like Twitter and Facebook lets their users approach data by connecting with a web service. The most conventional way of gathering data is straight from the files. It can be done by downloading from Kaggle or pre-existing information which sometimes stored in the common separated values, that is CSV formats. So once the data sources are identified, the data is checked for the duplication of data, consistency of the data, missing data, and availability timeline of the data. Further, data may be integrated, aggregated, transformed to produce data for a defined set of attributes, which are identified in the requirement page. This phase, sometimes also known as pre-processing, where you clean the data with whatever the missing data you have, because we know that the real world data is really dirty. So that has to be processed. That has to be transformed into a specific structures. So once you gather the data from the multiple heterogeneous sources, one has to make sure that all these data are structured into one single form. So this phase is very, very important phase. Third phase what we have is descriptive data analysis. The data now has to be examined before it is ready for use. In business settings, it is completely up to the data scientist to transform the data that is available into something feasible in a corporate setting. This is why the first thing to be done is exploration of data. We already covered how to find out the central tendency of the data in the previous lectures, where we saw that when to be used mean, median, and mode. And the data and its characteristics required inspection. It is due to the fact that different data types such as nominal, ordinal data, numerical data, categorical data, and all these data types needs different data handling. Next, the data is analyzed using univariate and bivariate data analysis techniques. And this will generate the descriptive information about the data. So this phase can also be used to establish the suitability and validity of data as per the requirement of data analysis. Also, this is a good time to review your project requirement with regard to collected data characteristics. Third phase, what we have is data modeling and model testing. After the essential stages of cleaning and exploring data, here comes the phase of modeling. It is often considered the most interesting part of data science lifecycle. Here, the first step to take while modeling data is to minimize the dimension of the data sets. So sometimes we use principal component analysis techniques or some kind of data reduction techniques to do this. Every value and feature is not necessary for the prediction of the data. At this stage, the data scientist needs to choose the essential properties that will directly aid the prediction of the model. Next, the number of data models based on the data are developed. All these data models are then tested for their validity with test data. Accuracy of various models are compared and final model is proposed for data analysis. So while training the system, sometimes there are rules. We have a 70-30 ratio or 80-20 ratio, whereas 70% of the complete data set is divided for the training data sets and remaining 30% of the data is used for the testing the data set. So once the system is ready using your proposed algorithms, 70% of the data set is actually used to train the model. And to test whether the model is actually trained, what we do is to test. So remaining 30% of the data set is used for testing the model. And according to the accuracy of various models which we have compared, further we need to check which of the algorithm is giving the best accuracy. Then here comes the model deployment and refinement. The tested best model is used to address the data science problem. However, this model must be constantly refined as the decision-making environment keeps changing and new data sets and attributes may change with the time. As I said in the previous slide, that 70% of the data set is used for the training, then 30% of the data set is used for the testing the model. So once we know that the system is fully trained, fully tested, then this is a time to deploy the model. One of the applications which I was talking in the earlier slide is to detect whether a given mail is spam or not. For a system to understand whether a given mail is spam or not is based on the different factors. Based on the different factors such as it checks the mail IDs, it checks the IP addresses, it checks the word patterns used in the mail, it also checks the word frequency, which actually helps to classify a mail as spam or not. So based on these different parameters, the system is going to be trained. So once the system is trained using these different parameters, then one can know that whether the given mail is spam or not. And after that, we can fully say that the similarity analysis can be used to detect the system. And after all these things, now we saw that how do we deploy the models here and further refined. And we also talked about different data applications where you saw the application using similarity analysis. It's applications related to the web searching, applications related to the healthcare domain, and also applications related to the transport sectors. We also talked about what are the common misconceptions of data science, which is Simpson paradox, data dredging, and also we discussed about correlation is not a causation. Then we also talked about different individuals who are involved in the data science project, starting from domain expert, business analysts, machine learning engineers, data engineers, and data architect. We talked about how do we define the life cycle of data science project, starting from requirement analysis phase to data collection phase, descriptive analysis phase, data modeling, and finally to the model deployment and refinement phase. In the next session, I'm going to talk about data pre-processing, where we will discuss about why do we need to process the data and what are the different quality measures which are very important for data pre-processing. Thank you.